So, welcome guys to lecture 6 of Python. My name is Pranav Vashin. I'll be your instructor for today. So, for the lecture is going on, if you guys have any questions, feel free to ask in PyQuestions and I'll be happy to answer them. So, before we move into today's lecture, let's look back at last week's homework and go through that. Okay. So, okay, this is the first one. Just let me just copy it. Cool. So you were asked to take as an input the height of a triangle and print it in the following pattern, the pattern being A, B, C, D, and goes on. So once you've completed till Z, I wanted you to start again from the beginning till A. So the first thing probably that we wanted to do is first take in this homework one. So we take in an input from the user, the height of the triangle. Cool. And since we want to print alphabets, if you've noticed in last week's lecture, the Unicode value of capital A is 65, and we also saw that the CHR command takes in Unicode value here, and it returns a respective character which matches the Unicode value. So we're going to use the CHR method to transfer the 64 into a character so that we can print it in the following patterns of A to Z. So the first thing that we do is we loop through the rows. So we loop through range 0 to n in this case. So the second thing we need is, if you notice this pattern, we have spacings here. There's space here and there's a certain number of space here and so on. So the thing that we would do is, I'll type in the commands first, then I'll explain you what it's doing. So this is what we first do. This for loop is to provide the spacing for each line. So if we look into the command, it goes from range I to n. The reason being is, if you look at the spaces, the first space is huge, second space is one less, the third space is even less, and the fourth one is less. So what happens is, it decreases by one space each number of time. And what better way to do that than start from the range of I. So I takes the value of 0 in the first time. So when it runs the first time, probably what it will do is it go from 0 to n. In case if I give it a length of 10, 0 to 10, the next time it would go to 1 to 10, which makes it which uh, which is one less value compared to the previous thing. The next time what is going to happen is it's going to reduce one more value, making it 2 to 10. The next time 3 to 10, and so on till at some point it's going to be 9 to 10. So only one space will be given, and finally when it reaches 10 to 10, the loop will exit and we're not going to have any space, which is clearly evident here. Or even you could have one bit of space here or just remove the space, it's your choice, but it reduces by one. So using this condition inside the range function makes sure that each time the spaces gets reduced by one. So now we've calculated how we can print the spaces here. The next thing what we need to do is to print the characters. So simple for loop for that is for k in range, another variable. So we start from 0 to I plus 1, or let's just write I plus 1. So what this does is, at the first time you just want to print one value, the second time you want to print two values, and the third time three values. So since I takes the value of 0 the first time, we're just going to increment by 1 so that range becomes 0 to 1. So one time the character gets printed, the next time I is 1, so this becomes 2. So two characters gets printed and so on. So in this way we can just print the character. So to print the alphabet, we're just going to use the CHR function, pass in the character value, and as usual we keep the end is equal to command so that it keeps on printing the same line. And to give it a bit of a space, let's just leave one space so that we get some spacing between the two alphabets. So one more thing we need to do is, we need to increment the character. So that if we keep on printing this, okay, let's just try printing this. Let's see what happens. You see, it's just going to print A, but we need to each time if it prints A, we just need to move to the next alphabet. So we're going to use chr plus equal to 1. So it'll next go to B, C, and so on. Oh, I'm sorry. CHAR. Okay. Okay. So the next condition I asked you to do is if the alphabet reaches Z, I want you to go back to A. As you saw, Z takes, I think, the value of 90 if I'm not wrong. So after 90, you have all these special characters, then it goes on to lowercase alphabets. So all we need to do is to have a simple if condition which checks whether the character value is exceeded 90, and if it is exceeded 90, we just want to initialize back to 65. So 90 I think is the value of Z, so 65 plus 25 in this case, so it would give you Z. So now if I print it, it's going to print properly. So to go through it once more, we take in the value of the height using n. CHAR stores the Unicode value starting from the uppercase A and moves on to lowercase a, uppercase Z. If we exceed uppercase Z, we're just going to initialize back to uppercase A. The first for loop is to loop through each row. The second for loop is to give us the spacing that's needed. And the third for loop is to print the alphabets. So whenever you do programs like this, try to modify or use the value of I in some way or the other, because you see that both of these loops use the value of I in some form or the other. I just modified it a bit so that it fits our condition to print the required pattern that we want. So yeah, cool. So we move on to homework 2, and I think that was a simple one. Yeah. So this homework was to get as an input a dictionary from the user, and I asked you to use the eval command. So for all those who don't know what the eval command is, I'll just illustrate the eval command here. The type function gives us the type of the, so if I in case enter 3, it's going to automatically convert it to integer. So Python automatically identifies the 3s in integer and converts it to int. In case I type in something like hi, it's going to say it's not okay, sorry. Cool. So automatically converts it to string because I've typed it in quotes here. And if I happen to give a list, it's going to smartly identify that it's a list and it's going to give me a list. It's going to store it as a list. And if I give in a tuple here, it's going to store it as a tuple. So the eval command, basically what it does is it identifies what type of data type you've entered, and it automatically converts it to that data type, and it gives it to, and it stores it name. So you don't have to hard code it to int or tuple here. You just have to type eval and it's automatically going to do the job to you. So to get the dictionary from the user, we're just going to use the eval command. So what we do is first get the dictionary from the user. We just get enter dictionary, and the next thing we do is we declare an empty dictionary which will contain the keys and values swapped in this case. So what we're going to do is we're going to take for I in A. So basically if we loop through I in a dictionary, I is going to take the values of the keys in the dictionary. So if I takes the value of keys, A of I is going to give me the value of the key, value respected to the key. So to switch the values in keys, what I'm going to do is I'm going to use this command and assign it to I. So to brief, what this does is I is basically the key of the dictionary, and A of I is the value respective to the dictionary. So when I do B of A of I, it basically says B of the value is equal to the key. So what this simple statement does is it switches the values in key. So in place of key, I'm storing the value, and I'm storing in place of value the key. So that's what I wanted to do. It's a simple statement which does it. So next we just print this thing. Just give a space and this print. So I'm just going to copy the dictionary that's here. I think it has a space. Okay, no. That's the dictionary. Okay, it's here. Cool. You can see that the values and keys have been swapped here. If Valorant is the value, it has been switched to the key, and if Riot Games is the key, a value has been switched to the key. So this simple statement, what it does, it switches the keys and values. So it's a small exercise to make you think of how you can access the dictionaries and make it switch. Cool. So next we move on to the third homework of last week, which was to okay, use this dictionary which contains a series of points. So A has three different points, B has three different points, and C has and D has three different points as well. All these points are stored in a tuple. So this 4 would be the tuple index of 0 of A, B would 1 would be the tuple index of 0 of B, C would be 5 would be for C, and D would be for 2. So what I wanted to do is to print the maximum value of all the tuples at the same index. So let me just copy this here. Okay. So in case of the index of 0, 4, 1, 5, 2, all are indexed 0. So all I wanted to do is to find the maximum of all these. So 4, 1, 5, 2, obviously 5 holds the maximum value, so I wanted you to print 5. It has to be index 0 here, it's been a mistake. So first thing we do is we just copy the dictionary here, which is points. So I'm just gonna copy the dictionary. And the next thing that I wanted you to do is we could have a list which has three different values, which is going to store each highest value in it. So the first index 0 would have the maximum value, which is 5. So 5 would come here, and the second would be probably 4, and the third one would be 6. So maximum just stores the maximum values inside those tuples. And we're going to declare n is equal to 0. You'll see why later. The first thing that we do is we loop in the range of 3. The reason why we loop in the range of 3 is we want to access index 0, 1, 2. So 0 is 4, 1 is this, 2 is this. So 0, 1, 2. So that's why you're using for I in range 3. So the next thing we're going to do is set n is equal to 0 again. Okay, so here's where the proper program starts. So for j in points.keys, so points.keys basically returns a list of keys. So in this case, it would return a list which has which would look like this: A, comma B, comma C, comma D. So this would what the points.keys would return. So for j in points.keys, basically for j takes in A, then it moves to B, then it moves to C, then it moves to D. It's basically looping through this list here. And points.keys returns a list of all the keys present. So first thing that we're going to do is sorry, index. We're going to declare a temporary variable which stores the first index value of the first key. So j at the beginning is going to have A, so it's going to be points A, and I is 0, so it's going to be 0. So which basically corresponds to 4 here. And when it loops to the next time, this is going to change to B. So it's going to take the value of 1. The next time it's going to take the value of 5 and 2. So once this loop is done, it moves back to the bigger loop. So I next takes the value of 1. So next time we come back, it's going to be A of 1, B of 1, C of 1. The next time it's going to be A of 2, B of 2, C of 2. Then next time it goes out of range, so the loop exists. So the next thing we do is if it's the first time, we're going to set the maximum thing to the first temporary variable. I'm doing it in this way so that it's much more clear to you. There's a lot of different ways you can do this. Okay. So what this does is we're going to assume that the first element is the highest number, and we're going to store it in maximum.i, and we're going to increment n plus 1. So, so the next time when it comes, we're going to check whether the temporary variable is greater than the variable stored in I. If it is so, we're going to change the variable stored in maximum to be temporary, because it's been proved that temporary is greater than the maximum value which is stored. So we're going to store it in temporary. What if the next temporary is greater than I? It's going to check again. Maybe the next number happens to be greater than the number existing. If so, it's going to just store it in maximum, and that becomes the maximum. At the end, all we need is a print statement which says maximum value at index I, sorry, is maximum. Simple. So I'll run through it again. I get it. It's a lot of code and a lot of conditions here. Cool. The first thing what it does, it loops through each index. We start with index 0, then move to 1, then move to 2. That's why this loop exists. This is as a counter. So if it's the first element, we just want to store the first element in maximum. So next we increment it to 1, so that the next time it checks whether the new element is greater than the maximum element. So for j in points.keys, what it basically does is points.keys returns a list of all the keys. So we start from a of 0, we move to b of 0, then we move to c and d. Once it's reached d, this loop will exit and it will move to the first loop. So 0 will be changed to 1. Next we move from a of 1, b of 1, c of 1. So what this does is it basically allows us to check the 0 index of different keys in this list. Then it moves to the first index of different keys, then to the second. So we're assigning the maximum value to the first temporary variable. Then as the upcoming temporary variable, if it happens to be greater, we're just gonna then assign it to the maximum. If it happens to be lesser than it, then we're not gonna assign it, obviously, because we only want the maximum value. So once this loop is exited, we would have the maximum value stored in this point here. We're just gonna print, say, maximum value at index 0 is the maximum at 0. So if you want, let me just print the maximum list to show you what it contains. It just contains the value of all the maximum values. That's all it contains. So hope you're clear with this. I'll be sending the lecture notes to you as well, so you can just go through if you didn't understand a bit more. So I think that should be clear. Cool. So that's it for last week's homework. I had to take time so that you guys understand the different conditions that and the different loops that's present. Cool. So we move on to this week's concept. We'll start with while loops in this week. So while loop is a different type of loop compared to for loop. So people call while loop to be a conditional loop. So conditional loop, basically what it does, it keeps repeating as long as some condition is true. So what we do to explain how a while loop works is the syntax is while, and you give a condition here, and you, as usual, you print. If the condition is true, whatever is printed under it would print. So I can just set this condition to be true default. Let's just say if the condition is true, it's going to have an infinite loop of printing highs. I'm just going to end it because. So, or if the condition is false, it's not going to print what's under the block. That's it. So it's a simple syntax. You first type in while, then you type the condition that you want, and if the condition happens to be true, the block under it executes. If it happens to be false, the block under it doesn't execute. So the thing with this is, you notice that this is an infinite loop, because the condition is always true. I've just set it to be true here, so it's always going to be true. It's never going to be false. So it's going to keep on printing high forever. So let me have a different condition to illustrate this. Let's just compare two loops. Let me have a comparison of the two loops so that you understand it much better. So let's say I want to print the numbers 1 to 5 or 0 to 4. For a for loop, all I would do is I would just say for I in range 5 and just print I. It prints from 0 to 4. If I want to do it with a while loop, it's a bit different. So what I would do is my condition is I want this number j to be less than 5. This is the condition. And I want to print 5 and I want to print j. It's going to show an error that j hasn't been assigned, or there's no instance of j here because j hasn't been assigned here. In a for loop, I automatically gets assigned to be at the start of this range, which is 0, and it increments automatically. Whereas for a while loop, you have to set j to be 0. Doing this would still print an infinite loop because j always happens to be 0 and it always happens to satisfy this condition, which is less than 5. So to modify this, we need to increment the value of j each time. So we just say j plus is equal to 1. So now if we print it, it's going to print from 1 to 4. So the point is, using a for loop, it's automatically going to assign I to be 0 and it's automatically going to increment I each time the loop goes on. Whereas for a while loop, you have to do all this process yourself. You have to set j to be 0 first and set the condition to be, j should be less than 5. If j is greater than 5, the condition becomes false. So I'm going to quit out of this loop. So I'm going to print j, and once I print, I want to increment the value of j to be plus 1. So j takes the value of 1. Then it moves on to 2, 3, 4, and when it becomes 5, obviously 5 is not less than 5, and it's going to quit. So if you just leave it like, if I delete this statement, it's going to have an infinite loop because j is always going to be 0 and j is always going to be less than 5. So j is always going to be printed. So it will be an infinite loop. So you have to make sure that, you increment j by 1 each time. So that's a simple comparison of the two while loops. So you can ask, why not use the for I in range function, why not use the range function in a while loop? So let's see how we could use it. I could say while I in range 0, 5, the same as I did, okay, for I in range 5, and try to print I. Let's see what it says. Okay, so I is already been defined. Let me just use another variable here. Cool. It's not going to print anything. The reason being that a has not been defined at all, so a does not belong in the range. So to use this function, you have no other choice but to declare a to be 0 and increment a each time. Only then it's going to print 1 to 4 because a for loop automatically declares I to be 0, whereas a while loop doesn't do that. So you have to hard code a to be 0, then increment a each time. But you might feel this is why do we need a while loop when we can use a for loop? Because for loop is much more easier than a while loop. But there are certain programs which are much more easier with a while loop, which you can't do it with a for loop. So let's see how that works. So I'm going to do a simple program using a while loop. Then I'll give you a task so that you guys can solve it. So using a while loop, I'm going to print a sum of n natural numbers. If you remember, it's a program that we did using while loops, for loops. Let's try it using a while loop here. So first we take in n as an input from the user. We get a number. So we need a variable sum which stores the sum of all the n natural numbers. So, and since we don't have a for loop which automatically assigns I to be 0, we have to ourselves assign I to be 0. So what would the condition be? The condition would simply be, if we do it in a for loop, what would the condition be? It would be for I in range 0, n plus 1. Because if you put n, it's going to go a little n minus 1. So we put n plus 1 so that we add till n. And then we're going to do, sum plus is equal to I. So the same thing what we're going to do is we're going to say for I less than n plus 1. This is the same as saying for I in range 0, n plus 1. So until I is less than 1, it's going to keep on doing the loop. The moment it becomes equal to n plus 1, it's going to exit. The same way in this case, I is going to, the for loop is going to run when it is always less than n plus 1. Once it reaches n plus 1, it's going to quit. The same logic is followed in a while loop. Oh, I'm sorry. The next thing we do is add I to sum. And one more thing that you have to remember is a while loop doesn't increment I, so we have to do it ourselves. So now we print sum. So if I just enter 10, I think it's 55, so it automatically prints the sum of n natural numbers. So difference between for loop and while loop. While loop, the condition is much more explicit here because we just give less than or greater than. And the next thing is we have to declare I ourselves or whatever variable that you're using ourselves, and we also have to increment the variable ourselves inside the loop. That's the important difference between a while loop and a for loop, because a while loop is a conditional loop and it's going to run automatically till the condition is false here. So this loop is always going to run until it becomes false. So remember that you have to have a condition here which makes it false at some point in time, which is going to be I here. So incrementing I at some point of time is going to be less than n plus 1, and that time is going to exit out of the loop, thereby printing the sum here. So that's the basic difference between a while loop and a for loop. So I'll give you a task here because I get it as a lot to process. So your task would be to write a program to calculate the factorial of a number. So to all those who don't know what a factorial is, the factorial of, let's say, n is n multiplied by n minus 1 multiplied by n minus 2 multiplied so on till we reach 1. So to give you an example, the factorial of 3 would be 3 multiplied by 2 multiplied by 1, which is 6. And if it was the factorial of 4, it would be 4 multiplied by 2, 3 multiplied by 2 multiplied by 1, which is going to be 24. So this is the basic formula. So factorial of a number n is basically n multiplied by n minus 1 minus 2 and so on till we reach 1. It just goes back once and we just multiplied it. So this is the factorial. So your program should look something like this. You should get an input from the user, enter a number, and if the user, for example, says 3, I want you to output saying the factorial of 3 is, then say 6. And I want you to use a while loop, not a for loop. So I'll give you guys like 6 to 7 minutes to solve this. Since for while loops are new to you, I'll give you a few minutes to solve. And if you guys have any doubts, you can ask them in questions. I do understand the fact that the homework was pretty hard, but I'll be giving more homeworks like this, so as you keep on solving each week, you will get the hang of it and keep understanding, because programming is all about practice. So at the beginning, it's going to seem very difficult to you. So as you understand and as you practice, things will be pretty easy to you. So I'll be giving a lot more on for loops and while loops as well, so you guys get really comfortable with it. So yeah. If you guys maybe want, I'll add a bit more hints next time in the homework so that you guys can try to figure it out. I'll add hints maybe for this week's homework so that to make it a bit more easier to you guys. I feel with for loops and while loops, it's all about experimentation. So you try different commands and you try different things, so you'll get it at a different time. Oh, okay. Oh, I tried to keep it much as what I thought in the lecture, but okay, cool. I feel there weren't elements in the homework which I didn't cover, but okay. And by the way, if you guys solve the task, do not post it in 5 questions. Just wait. So after a few minutes, I'll be discussing it with you. Cool. We'll wait for a few more minutes for the others to solve. Oh, for this thing, okay. If you don't use this, okay, we use sum because we need a variable to store the sum, and we obviously declare it to zero because we want to start the sum from zero. So if we don't have this here, it's going to show an error because sum is not defined, and we need an I because we don't have a for loop which automatically declares I to be zero. So yeah. Yeah, I'll give you guys like 1 or 2 more minutes, then I'll walk you through the solution. Okay, let's see how to solve this thing. So the first thing, as usual, you need to get in an input from the user as an integer. So we get an input from the user. The next thing we do is we need a variable to store the factorial. So previously we had sum, and this time we're just going to use the variable called factorial here. It stores the factorial. Initializing it to 0 will pose a problem because we're multiplying the numbers here. So if I happen to multiply anything with 0, then the result is going to end up with 0. So it's better that we initialize factorial to 1. So use when we using the variable to add something to it, we use 0. When we using the variable to multiply something to it, we use 1, because 1 multiplied by anything is the number itself. So 1 is not going to change anything, but using 0 is just going to give the whole output of our factorial as 0, because we multiply it to n minus 1, n minus 2. It's going to result in a 0, not going to give us the factorial. So we're initializing factorial to be 1 in this case and not 0. And the usual thing, we need a variable, so we'll just have I to be 0. So okay, we'll look back at the equation above. So factorial of n is equal to n into n minus n into n minus 2 and so on till we get 1. But we could also write it in the opposite way. We could start from multiplying from 1, go on to multiplying to 2 to 3 and so on till we reach n. We could do the reverse order because it's essentially the same. Going back from n and going forward to n is still going to be the same thing. So to make the loop much more easier and to make it much more readable, I'm going to start from 1 instead of going from reverse. So we'll start with 1. So we'll declare we declare I to be 1 in this case, since we can't multiply by 0 again. So we'll start with 1. So the loop would the condition would be is we're just going to multiply till we reach n, because we don't want to multiply after n. It has to be 1 into 2 into 3 into 4 and not 5. So we'll stop with n. So the condition would be to restrict I to be less than or equal to n. We wanted to multiply n, but we don't want to exceed n. So that's why less than is equal to come. This condition basically means this condition will be true till it goes above. So less than n would make sure that if I becomes n, it's going to exit. Whereas if less than or equal to is given, when I only it becomes higher than n, it's going to exit the loop. So to calculate a factorial, we're just going to multiply this by I. Then we increment I as usual. Then at the end, we just print the factorial of, let's just print the number here. Is okay. So to walk you through this, I takes the value of 1 in the first case. So factorial has already 1. So it would start from 1 multiplied by 1, which is essentially 1. Then I increments to, we're incrementing I by 1. So next we would multiply it by 2. Then when I takes the value of 3, we multiply by 3, 4 and so on till we multiply by n. Once I reaches n, the next time it becomes n plus 1, but n plus 1 is not less than or equal to n. So it automatically quits. So the simple command here basically multiplies or does the factorial calculation. So let me type 8 here. I think 8 factorial is 40,000. Think what happened? Oh, I'm sorry. Is equal to. I'm sorry. Should work now. I think I've already used n somewhere. Oh my god. Okay. It's number here, not n. Again. Cool. Works out. So I missed an is equal to here. So it's factorial into factor is equal to factorial into I. So this command here multiplies or does the factorial calculation. So it starts from 1, it increments till we reach n. So once everything has been multiplied, this condition becomes false. So then we just go back. So yeah, factorial of 0 is 1. So we could include the condition here because we just say 0 is still gonna be 1. So it still remains true. So yeah. So that's it for the factorial program. So we've seen while loops and for loops. There's a combination. We've also seen if and else statements. So combining an if and else statement with the loop gives us something unique called the loop else statements. So it's just loops combined else statement. Yeah. So I'll illustrate how that works. So let's start with the for loop. Let's just have a for loop which prints from to I. It's just going to print from 0 to 3. So a loop else statement is after a for loop, you just add an else loop. So this acts as the if block and this acts as the else block. But instead of the if block, we have a for loop here. So let me just print loop has ended. Let's see what this does. So you could see it's nothing different. So it finishes printing from 3 and it prints loop has ended. So instead of this, we could just say this and it's going to do the same thing. But there is one catch with having an else statement here. So the thing that makes it different from not having an else statement is, in case in the loop I have a break statement here and I have an else statement here which says the loop has ended. Okay. You can see that break statement breaks out of the loop as soon as the statement is hit. So once when I takes the value of 0, it's going to break out of the loop. But there's an interesting thing that you can see. Once it breaks out of the loop, this statement does not get printed. So usually if we have a statement like this outside the loop, it's going to print that print the statement. But what the else statement does is, in case the loop has been broken in between its iterations, it's not going to print this. The else statement is only going to run if the for loop finishes all its iterations, which means it finishes printing from 0 to 3 and there is no break statement which breaks it in the middle of the loop. So only then the else statement is going to run. So that's the only difference of having an else statement and not having an else statement. So in case you have a break statement or something, this code is not going to run. But if we, let's say I print ended here, this is going to run, whereas the statement above is not going to run. So if I just remove this, it's not going to run. Yeah. So the else statement will not run if the loop breaks out in between and will only run if the loop finishes all its iterations. So let's see one use case of it. Let's just say I want a program to make sure the user doesn't enter a number less than 0. So in case a user happens to enter a number less than 0, I just want to quit out of the loop. So this program is to calculate the sum of numbers. So what we're going to do is we're just going to ask the user to input numbers. We're just going to ask the user to keep on inputting numbers. So by any chance, if the user inputs something less than 0, we're just going to abort and not print the sum of numbers. But if the user happens to input all the numbers properly, which happens to be 0 or above 0, we're just going to print the sum of numbers. So we're going to have a sum variable which calculates the sum. We're also going to have an answer variable. I'll tell you how this is useful. So the loop is going to run till the user inputs y. I'll finish the loop so that you understand why this works. So we get in a number from the user. Cool. And next thing is we check whether the number is less than 0, because that's our main motive here. We don't want the user to input something less than 0. And the next thing is use the print statement. In case the user happens to enter something less than 0, we say the number entered is below 0. Let's just say about something. Yeah. And we just break out of the loop then and there, because we don't want to print the sum. If not, we're just gonna add the number to the sum, and we're gonna ask, this is where the answer variable comes in. So the answer variable is just to ask whether do you wanna enter more numbers, and it's just an yes or no question, so the user gets to enter y or n. If the user inputs a lowercase y, the loop runs again. If the user enters anything else other than a y, we're just going to break out of the loop, and we're going to print the sum of numbers is sum. So this whole program is to print a sum of numbers which the user will keep on inputting. So each time after the user enters a number, we're going to ask whether the user wants to enter more numbers. If the user happens to input y, this loop runs again, which is basically asking the user a number and incrementing it to sum and so on. If the user inputs something else, we're just gonna cancel this loop, and we're gonna print the sum to where the user inputted the number. So what this does is it's gonna check whether the number inputted is less than 0, and if it happens to be 0, we're just gonna abort and not print the sum. So this is where the else statement is useful. So I keep on inputting numbers, and at any point, oh I'm sorry, 13, and I just enter n. It's going to print the sum of the numbers that I've entered. Let's see what happens if I enter something below 0. So let's say I enter minus 13. So it says the number entered is below 0, and it aborts, and it does not print the sum of the numbers, because that's our essential condition. If a number happens to be less than 0, we don't want to print the sum. So that's what the else statement takes care of. Since the loop broke in between, this statement will never be, this statement won't run. In case we didn't have the else statement, let's just say we just had it like this. If the user happened to input something, less than minus 10, it's going to print the sum of numbers, which we don't want, because we only want the user to input positive numbers, and we only want to add positive numbers. So in this case, it's useless, because even though the user has entered something below 0, we're printing the sum. So the else statement, what it does is it makes sure this does not happen, and makes sure that if the loop is broken in between, this statement is never going to run. So only if the whole loop runs properly, this statement is going to run. At any point in time, if the loop breaks out, the else statement is never going to run. That's the simple point of having a while else or a for else. So to make sure it's much more clear to you, I'll give you a task to solve. So I wanted you to write a program to input a number and check whether it's a prime number or not. Simple. To those, in case you don't know what a prime number is, a prime number is a number with factors of only 1 and the number itself. So the output would be like this. I want the user to enter a number. So if the user enters 7, I want you to say 7 is a prime number. And and in case user happens to enter 10, which is not a prime number because it has factors of 2 and 5, so we're just going to say 10 is not a prime number. Simple program, so you just have to check whether the number is a prime number. So try to use the for loop here, because the for loop is much more easier. Use the for and else block here, so you will see how useful it is having an else block here. So I think I'll give you a few minutes to solve this. Maybe give you a hint of to check if a number is prime number. What you would probably do is, if the number is 7, I will first check whether 7 is divisible by it's obviously going to be divisible by 1, so I'll check whether it's divisible by 2. So what this does is this gives us the reminder. So if this happens to be 0, it is divisible. If it does not happen to be 0, it's obviously not divisible. Then I will check if whether 7 is divisible by 3, 7 is divisible by 4, till I get to 7 is divisible by 6. And in any of these cases it happens to be divisible, it's obviously not a prime number, because prime numbers can only have a factor of the number and 1. So in this case we're just going to break out the loop and print it's not a prime number. Else it successfully runs this whole loop, we're just going to say this is a prime number. That's all. So you will see how the for else statement is useful here. So this is just to give you a hint of how to calculate a prime number. So make sure you start from 2 and not 1, because 1 is obviously going to be divisible, and make sure you end before the number, because 7 divisible by 7 is also going to be equal to 0. So the percentage gives us the remainder of the calculation. It's called the modulus function. It gives us the remainder of a certain division operation. So 7 modulus 6 would give us 1. I'll give you guys a few minutes to work on this and solve. So this is to add. So if user inputs 2 in this case, so num will take the value of 2, so we are adding sum to 2. This is just saying sum is equal to sum plus num. So when user inputs 2, we'll add sum to 2. Then when user inputs another number, we'll just add that number, and so on. So number is basically a variable which stores the user inputted number. So this basically keeps on adding the number that the user inputs. That's why we use the sum plus is equal to num command. So num stores the user inputted value, and gets added here. I would recommend you not to, because the others have to try as well. So in case it is correct, the others probably wouldn't try. So either way, just ask. I'll still be going through the solution. So fine, I'll have a look. I think even then people would be probably tempted to look at the answer. So let them solve it, let them think and solve it themselves. So yeah. Cool. Then what you do is after I discuss the solution, just post it. Then I'll have a look at it and let you know. Yeah. So once I discuss the solution, you can just post it. So I'll have a look at it and let you know. I'll give you guys another minute, then I'll walk you through the solution. Okay, let's see how to solve this thing. So as usual, the first and foremost thing is to get as an input a number from the user to check whether it's a prime number or not. Then I'll solve the program two different ways. I'll solve it in the first way. Then I'll ask you guys whether you could make it much more efficient. Let's see what you guys say. So we want to divide it starting from 2 till the number. So n, not n plus 1, because we just stick with n. So the next thing we do is if you could just check whether if the number when divided by I returns is divisible. If so, we print num is not a prime number. And as soon as this is done, we don't have to check for the other conditions, so we can just break out here. So this is where the else statement is very useful here. If the whole loop happens to run without a break, it means that none of the numbers were able to divide this, which means it is a prime number, because factors from 2 to n do not divide n, which proves that it's a prime number. So we just say is a prime number. Why is it minus 2? Okay, I think, oh my god, I keep using the wrong variables. Cool. It says n is not a prime number, 7 is a prime. Cool. So do you guys have any idea how to make it much more efficient? Yeah, that would be right. You could use yeah. So the point is, if let's take a number 7, we don't have to check till 7 is divisible by 6. It's enough if we check till half of the number, because we know that let's say if a number is 8, we obviously know that 4 divides 8 obviously, but going above 5 is useless, because we know that it's not 5 is not going to divide 8, neither is 6 nor is 7, and it's only going to divide by itself. So it's useless checking after half of the number. So what we probably can do is stop till half of the number. So in case if we have a huge number like 1000 something, we don't have to check till 1000. We could just stop till 500. So that's a more efficient way of doing it. But there's one small issue with it. So let me just declare it to be a different variable called limit. So what this does is we just check till num by 2. But there's an issue with it. Num by 2, if the number happens to be 7, n by 2 would give you 3.5, which is a fraction, and we don't want a fraction. So all you have to do is you have to convert it to an integer here, and it's better to add +1, because in case let's say maybe a number 10 divided by, no, it's not 10, 11 divided by 2 would probably okay, that's okay, maybe some number divided by 2 results in 3.333 or something. So it would get truncated to 4 rather than 3 rather than 4. So it's better that we add +1, so that we check one above it as well. So you could not add this, but I mean it's better that you, because it gets truncated to a value lower than it, so you never know if it's going to be proper. So this reduces the computation power, and it increases the efficiency. So you don't have to check till 99 here. It would stop till 51 in this case. So maybe let's just print limit to see what the limit is. So see, it stops till 51. It doesn't go till 100. So we don't have to waste this loop running till 99. So it's a simple thing to optimize the loop. So I feel that's enough for loops and loops this week. So before we wrap up the session, let's look, I showed you guys the random module, I think 2 weeks back. So let's look at the math module, since we've been doing a lot of mathematical calculations. So the math module contains different mathematical functions. So okay, I told you I'll look at your program as well. Yeah, so as I said, your program is still efficient, but using the for else statement is much more efficient than using the if and else statement. So using the if and else using the else statement gets rid of the variable is prime, so you don't have to have a is prime variable in this case. So that's the use case of for else, which totally eliminates the use of a variable which you need to check or not. So yeah, otherwise I think your program would be efficient as it is. So the math module, as I said, it contains a lot of mathematical functions. So we'll have a look at a few of them. As the random module, we use import math to import the math module in small case. So okay, let's look at a few functions. We have a function to calculate the square root of a number. So to calculate the square root, we say math dot square root, which is sqrt, short form of square root, and we input the number. So square root of 36 is 6, square root of 81 would be 9, sorry, is 9, square root of 4 is 2, and so on. It returns the in a decimal point. It does not return in integer, so it always returns in decimal point, so that in case it gives square root of 20, which is not a perfect square, it returns it in decimal points. Okay. So the next thing is we have a function to calculate the power of a number. So if we want to calculate 3 power 3, I would use the command pow, which is a short form of power. So to calculate the power of 3 power 3, I would say 3. This is the number that you want to calculate the power of, and this is the exponent of the power. So this is 3 power 3. If you want to calculate 3 power 10, I would do this. It would return 3 to the power of 10. Or if you want to calculate 10 to the power of 10, I would just do this. You do have, since we saw the factorial program here, you have a function called factorial, which calculates the factorial of numbers as well. Simple command for it as well. Math.factorial is the function name. So you just input a number. So factorial of 8 would give you 403.202. I'm not sure whether it works with my negative numbers. Let me just try with 0. Okay, it returns in that case. Cool. So factorial, since this factorial is not defined for negative values, if you try to enter a negative value, it's going to give you a value error stating the function is not defined for negative values. So it only allows positive values. Okay. So you have to you can calculate the greatest common divisor of two numbers. So to all those who don't know what a GCD is, it's a common number which divides both. This is a common divisor for both. So the GCD, you don't have to type greatest common divisor. All you have to type is GCD. So the greatest common divisor of 6 and 4 is obviously 2. So 2 divides 4, 2 divides 6, and that's the greatest thing which can divide 4 and 6. So that's the greatest common divisor. A few more functions. We have a function called the floor function. What it does, it returns the largest number less than or equal to x. So what that does is, in case I give 12.3, it's going to return the largest number that's less than or equal to x, which obviously in this case is 12. So in case I give like 13.8, the largest integer which is less than or equal to x is again 13, so it's going to give that. There's a function which does the absolute opposite of it, which returns a number just greater than or equal to x. So in case I use the same function here, I use math.floor 13.8, it's gonna give ceil. It's called the ceiling function. So the floor function, as the name suggests, returns a number integer lower to this. A ceiling function or a ceil function returns a number which is greater than this. So this would give 14. So the floor function returns the largest integer which is less than or equal to x, and this returns, my bad, is the the smallest integer, which is greater than or equal to x, which is 14 in this case. There's so many functions. I'll add a link to the Python documentation in the homework so you can have a look at all these functions. Uh, to all those who know what a logarithm is, you also have uh, functions which take the logarithm to base of 10. So if I just say math.log 10, this is to the base of 10. 2 is going to return logarithm of 2 base 10. So logarithm of 10 base 10 is and if you don't understand what logarithm is, it's absolutely fine. To all those who know what logarithm is, I'm just explaining them. You can also take logarithm to any base that you want. So you have a common logarithm function, which is math.log. So the first thing you enter is the value that you want the logarithm for, in case if I want 2. And here I enter the base. So if I want the logarithm of 2 to the base 10, I would enter 2 comma 10. So yeah. So as you can see here, this also takes logarithm of 2 to the base 10. This also takes the logarithm of 2 to the base 10. But the log function is much more accurate than the log 10 function. So you can see it is much more accurate because it gives it to one extra decimal point. So it does not round off 1/4 to 2. It's much more accurate, the log function. So you have a lot of functions like this. Maybe like show you how to. So this is how the Python documentation looks like, just so you guys are familiar with it. So this is the documentation for the mathematical module. So you'll have all these different functions here. So if you just look at this function, it can say math factorial. You have a definition for it which says it returns the x factorial as an integer. And if maybe you want to know what the GCD function is, it has a definition which says return the greatest common divisor of a and b. So that's how the Python documentation is. It's very simple and very easy to understand because you have the function here and it also talks to how to use the function, what the function does. So it's much more easier. I'll leave a link to it in the homework files as well. So that's for the math function. In the power function, yeah, instead of using, see, if you use n star star 2, you can only, this is squaring it. So if you want, it's much more easier if you use it. I think it's the power function. I think it's more faster. I'll maybe check the runtime of both of them. I probably feel the power function will be much more faster rather than using the double asterisk here. Okay. Cool. I think that's it for this week's lecture. So your homework would involve the math module. I think you'll be using the quadratic equation to calculate roots of numbers, and you will also have 2 more exercises on loops. I'll try to give more hints so that it's much more easier to solve because this week's homework is a bit difficult. So I'll give you like hints to solve it. So that's it for lecture 6 of Python.